quotient rule. So these you have to know. Okay, it will save you a tremendous amount of time. At the very least, like there is absolutely no way around it. You have to know the derivative for sine and cosine. Technically, the other four you could get by doing quotient rule, but it's going to be really annoying if you have a problem with, you know, x squared secant of x plus tangent x sine x, and you have to change everything into sines and cosines and do multiple product and quotient rules. It will save you time to know these derivatives. Some hints, if you look at all of your cosine, cosecant, cotangent, what do you notice about all their derivatives?
They got cos.
The original have cos, and the derivatives are all negative. So if you have a cosine, cosecant, cotangent, the derivative is negative. Otherwise, they're very closely related. You know, sine and cosine, their derivatives are just each other. The derivative of tangent is secant squared, so cotangent, it's a cos, so it's a negative cosecant squared. Derivative of secant is secant times tangent. Derivative of cosecant is negative cosecant cotangent. So we can see like secant and cosecant, sine and cosine, tangent and cotangent, they have some similarities when we're looking at their derivatives. Any questions there? Other than I just told you you have to know this, so, but we could derive them if we had to. So if I asked you to find the derivative of x tangent x, something that I've noticed on the homework is you guys are struggling with not just doing the derivative of each of these separately. This is x times tangent x. So I see I have a variable here and I have a variable here. So what do we have to do? Product rule. So derivative of the first, derivative of x is 1 times the second plus the first derivative of the second. What is the derivative of tangent?
Secant squared.
Secant squared x. So we just get tangent x plus x secant squared x. Derivative of cotangent cubed t. Okay, that's just another way of writing cotangent to the third.
Do you not have to do like another product rule for?
No, because we already did the derivative once. If I ask for the second derivative, you'd have to do product rule again.
That's the part that we didn't.
You just want to keep going with it?
Well, if it's not complete.
With these trig functions, a lot of times, I mean, it gets uglier as you do derivatives. It's not like polynomial where it gets nicer looking. We know if it's like x to the third, we can just bring down the exponent. But can I do that when I have a cotangent t inside? No. So we talked about this with one yesterday. This means you have cotangent t times cotangent t times cotangent t. So what do we have to do?
The
Product rule 3 times. So derivative of the first, derivative of cotangent is and this other two stay the same. Plus, so this time the first and the last can stay the same, but we have to do the derivative of the middle. It's just a cotangent, so derivative of cotangent is negative cosecant squared. Plus, this time the first and last stay the same. Or sorry, first and second stay the same. Derivative of the last one, negative cosecant squared. What do you notice about these? they're all the same, so this is, if you add their coefficients, -1, -1, -1, we get -3. Cosecant squared t, cotangent times cotangent is cotangent squared t. C. This is the secant of z divided by the square root of z, or z to the 1/2. There's actually a couple ways I can do this problem. What are your thoughts? Quotient rule, that's the first one. What's another way?
Product rule.
Product rule. You would have to bring that z to the 1/2 up, so it becomes z to the -1/2, and then you would do product rule. So both of those are legal. Do you guys have a preference?
Product.
Product?
Actually, I don't care.
It doesn't matter to me. Product? Okay. So the reason we can just bring this up is because it is just one term on the denominator. Otherwise, you would be stuck with doing the quotient rule. Product rule is probably a little bit nicer in general, because we don't have a fraction to deal with. So if I do this, derivative of the first, derivative of secant is secant tangent. Derivative of the first times the second plus the first derivative of the second. So that would be -1/2 z to the -3/2. Not much you're really going to be able to do to clean this up. You know, if you want to put your z in front here, you can. Order doesn't matter. I would appreciate if you bring coefficients forward, so I'm going to put -1/2 z to the -3/2 secant of z. Is that okay? This one. Is quotient rule an option, or is product rule an option here? No, so you have to do quotient rule. Why don't you guys try it? So we know this has to be quotient rule because we have the more than one term on the bottom. So we have low, the bottom one. So 1 plus tangent x. D high, derivative of secant is secant tangent minus high d low, derivative of the bottom. So derivative of 1 is 0 plus derivative of tangent secant squared over low squared. As far as simplifying this, you can distribute. It's not going to gain us a lot. It's pretty ugly. We get secant x, tangent x, plus secant x, tangent squared x, minus secant cubed 1 plus tangent squared. Is that okay? Couple more examples and then we're going to stop for now. So, we have an object at the end of a vertical spring is stretched 4 centimeters beyond its rest position and release at time 0. So I've got a spring, I'm stretching it down 4 and then I let go. So we know it bounces up and down, right? So the position is given by this equation. Find velocity and acceleration. What's velocity? First derivative. I think I gave you another slide after this so you have room to write. So velocity is just the derivative of position. Do I have to do the product rule?
No.
No. I have 4 times cosine, but the 4 doesn't have a variable, so it's just a coefficient, it stays. So it's just 4 times, what's the derivative of cosine? Negative sine t, so we just get negative 4 sine t. That's my velocity. How do we get acceleration?
Second derivative.
So we have negative 4. What's the derivative of sine? Cosine. There we go. So far, so good? Last one. Find the 27th derivative of cosine. Okay, here we go. So what's the first derivative? Negative sine x. What's the second derivative?
Cosine x.
Right, derivative of sine is cosine, so that negative stays, so negative cosine x. Third derivative, what is the derivative of cosine? So 2 negatives would make it a positive sine. Fourth derivative, what is the derivative of sine? Cosine. What do you notice? Yeah, we are back to where we started. So this would be my 5th, 6th, 7th, 8th, and so on. So if we think we want the 27th derivative, so if I think multiples of 4, I could go through my list 6 times, that would be the 24th, then 25th, 26th, 27th. So my 27th derivative is
Negative sine x. No,
positive sine x.
my bad. I put it down.
Do you guys see how I got that? This next part is a little bit different, so I'm actually want to stop and let you guys practice practice the derivatives of the trig functions before I do the limit portion of this section. So we are on the day